Okay, so hello. Today we'll be learning how to check clock timing violations in Cadence Genus tool. So let me start the terminal. Okay, so I've already copy pasted some of the standard commands so that I can save some time. So I'll directly copy paste from here. First we have to load the library file. This is the library file. So here I'll just paste it. Press enter. The library is loaded. Next I need the Verilog file, which I am again simulating a 16-bit counter. I will copy it and paste, press enter. Afterwards I need to elaborate the design. Here I have to enter the name of my top module, that is counter 16 that I have used. So I'll run this command. Once it's elaborated, the next step is reading the SDC file. What is SDC? It's basically a constraint design file that where you need to basically supply your timing constraints. I'll show what I've written there. So I'll go to my constraints folder. This is the constraint file I've written. This is the main line of the code where I'm specifying that the clock to be used in this design is of time period 10 nanoseconds, and make sure that this name CLK clock matches with exactly what you have used in your Verilog file. For example, here if I show my Verilog file for 16-bit counter, I have used the name CLK for clock. So that same name should be present here. If there is a mismatch, then your simulator won't work perfectly. These are optional text lines. Right now we don't need them, so I'm putting them out as comments only. This is the only line that we need to specify time period. So let's simulate this thing in 10 nanoseconds clock and let's see what results exactly we are getting. So I'll copy paste this STC command. Okay, so both create clock and get ports is successful. Afterwards I need to synthesize my design. To synthesize in, I'll again copy paste this command here. Okay, once the design is synthesized, I need to generate the netlist for my design. So again I'll copy and here I'll paste. Okay, so the design file is now synthesized. The netlist is being generated. Afterwards I need to check design if there are any DRC errors or any such kind of errors. For that I'll run this command check_design. So there are 0 errors. Afterwards I'll move on to time elaboration, which is not really necessary, but it's still a good practice since it tells you something about like how much memory is being consumed at what particular time to run your design. Afterwards, before I run this command, there is another command like this one. Now if your Genius version is a bit older, it won't support this command because it basically tells at what particular time is your clock violation happens, what is the limit and all those things directly. So let's run it. For my system it doesn't support. Like here it's saying the design is the use report timing length. So my Genus is a bit older version, so I need to calculate the slack manually. So I have this command for that is report timing. I'll copy this thing. Afterwards I'll paste. Yeah, now I get something called as slack. So this is in terms of picoseconds. Okay, you have to note this thing. This is whatever timings you are getting is in terms of picoseconds. Here PS is written. So what is this slack and how can you calculate your clock frequency or clock violation from this one? So basically what is a slack? Like you have this much of time left before the next clock pulse comes. Understand it with kind of an analogy. For example, there's a bus stop. The bus comes at 8 a.m. but you reach at 7:55. So you have plus 5 minutes of slack time. That means you are ahead of your time. But if you reach at 8:01, then it means you have minus 1 minute of time slack. That is, you are late, you will miss the bus. The same thing this slack tells us, that we have positive 7.7 nanoseconds. Since this is in picoseconds, I shall convert it to nanoseconds. It becomes 7.71. I have this much positive slack before the next clock pulse comes. So what is the maximum frequency before time violation occurs? This is a simple way to calculate that thing. So I will calculate the path delay. I have taken a 7.411. You can take 7.7 because earlier when I was calculating, I got 7.41 for some of my other design. So this is your slack value in nanoseconds. This is the clock time period that I am using, as I showed in this your SDC file that I'm using. I'm simulating it at 10 nanoseconds. So that 10 minus the slack time you got 7.411, you will get 2.589 nanoseconds. That is the minimum clock period that your design can support. If you want to convert it into frequency, you can simply reciprocal it and you will get 387 megahertz. This is your maximum clock frequency or T clock before any time violation occurs. Okay, next there might be a question, a basic criteria, like what if I use this as my SDC file constant, timing constant, instead of 10 nanoseconds. Like earlier I was using 10. So instead of this, if I use this particular value, that is 2.589, so should I get the slack as perfect 0? The answer is no. So let me run this thing. I have already run this thing that I entered. Instead of 2.5, I have entered 2.3 nanoseconds in my next STC file. So technically what I am expecting is there should be a clock timing violation, but that doesn't happen. So here you can see instead the slack got reduced to 10. That is very close to 0. Earlier it was 7710, right now it's 10. So definitely the slack time has reduced from 7000 something picoseconds to 10 picoseconds, but at the same time I'll show you, like here the area count was, okay, let me do in this one only. I'll report the area, report underscore area. Okay, so the area that I got last time was 1802, but this time the area that I got was 1876. So though there has been a reduction in time slack from 7000 something to 10, but the area is increased, which specifies that the tool is optimizing the design so that it's increasing its cell count and number of cell area, the amount of cell area, so as to manage the reduced clock period. So that is how your tool optimizes it. Now next question can be how to reduce it to perfect 0. There is no definite answer or way right now, because as I said, if your Genus is a more previous version, you can simply run this command and you'll get the answer. But since my Genus doesn't support this command, so I'll have to calculate it manually through report timing. So it's more like a hit and trial based thing. You have to run it multiple times through iterations till you get a very near 0 value. Thank you.